I'm starting to get a little tired of the amount of obviously AI written content that's appearing everywhere. Not because AI is inherently evil, but because when it's obvious, it gives the impression that the author just doesn't care. So, I wanted to train an AI model to detect AI writing. The plan is simple. Step 1, get lots of examples of human and AI written text. Step 2, train a classifier to predict whether a given piece of text was written by an AI or a human. And step 3, profit? With our trained model, we can build all sorts of cool software on top of it. For example, you could make a platform like GPT-0 or Grammarly that scan for AI text. Or you could make a Chrome extension that automatically blocks anything that was written by AI. Our first hurdle is getting human written text. I chose to get it off of Wikipedia. This is for 3 reasons. Firstly, if we wanted to be extra careful that we only have human written text, we could get it off pre-2022 Wikipedia, but honestly I'm not too worried about it. Secondly, we need to think about scope. For a proof of concept, it's best to keep scope small by training on one genre of text. If this works, we can then think about looking at more sources. The third reason is that it's easy. Wikipedia has an easy-to-use API, and its pages all link to each other, making it really straightforward to crawl and scrape. My crawler worked like this. It started with a list of the top pages on Wikipedia. I then pick one at random, scrape 2 paragraphs from it, and then get the links to 2 of its children, and add those to the list of pages to scrape. Then you can just repeat this process until we have enough data. I stopped at 10,000 different paragraphs across 5,000 different Wikipedia pages. I also had to be careful about what I considered a paragraph, making sure to filter out anything that looked like bullet points, a citation, or equations. If you're curious about the details, I suggest taking a look at the code on GitHub. Next, we're going to need AI-generated text. To do this, we can just get an AI to write some text for us. The difficult part is planning our approach and executing it at scale. Firstly, we need to make sure that our AI-generated text is as similar to our human-written text as possible. Why? Well, imagine our AI text was all fiction stories and our human text is all Wikipedia. Then our model wouldn't be learning to detect AI text, it would be learning to detect fiction. So specifically, we want our AI text to look like text from Wikipedia. The easiest way to get Wikipedia-style AI-generated text is by asking AI to rewrite the paragraphs that we just scraped. I chose to do this in a 2-pass approach inspired in part by GPT-0. See, if we gave the AI an example of Wikipedia text and asked it to rewrite it directly, we would really get a mix of human and AI text. But if we first get the AI to summarize the key points, then ask it to write a paragraph using only the key points, it's a better representation of AI text, and I think it more accurately models how you would use an AI to write paragraphs for Wikipedia. To implement this at scale, I used the OpenAI Batch API. This was an easy way to process tons of requests in one go, and cut costs in half too. The Batch API lets you make a bunch of requests at the same time, and gives you the answer back within 24 hours, which is perfect for generating our datasets. I also chose to use GPT-5 Nano to bring the costs down even more. And now finally, after doing all of this, we have our dataset of human and AI written text. Oh, hang on, sorry, I'm getting a call. Hey, what's up? Oh, there's already a dataset out there for training AI detectors? And it has way more examples across way more domains and uses a lot of different models to generate the text? Well, at least I learned a lot by making my own dataset. And this does give us something to compare against. We can train our model on our dataset and then see how well it generalizes to the RAID dataset. So this is actually a great opportunity. We'll get back to RAID shortly, but first we need to train our model on our data. It was pretty straightforward to implement the data processing and model training with HuggingFace. I knew I wanted to fine-tune a pre-trained model because it would be a lot easier and is pretty suitable for our use case. I went with the BERT base model after trying a few different options. I played around with some hyperparameters and using methods like LoRA, and I was able to get the accuracy up to 96%, which I'm incredibly happy with. And to be honest, I was a little suspicious of just how high this accuracy was, so I wanted to write a quick sanity check that will let us test data on the fly. While I get that ready, I just wanted to quickly thank you all for the support I've received on my past few videos, and if you enjoy the content, subscribing would be greatly appreciated. Okay, so here's how the script works. You can put any piece of writing into it, and then it outputs whether or not the model thinks it was AI generated, and also gives the probability, i.e. how certain the model is in its decision. Now, if I take the paragraph directly from Wikipedia and I run it through the model, it says that it's probably human generated. And now if I ask ChatGPT to rewrite the paragraph, you can see that our model is indeed able to figure out that it was made by AI. So indeed, it does seem to be working as we expected. Now let's see how it compares on someone else's dataset. RAID is a large dataset of human-written and AI-generated texts. It has examples from 8 different domains and 5 different model families. And they also have a leaderboard so we can see how our model stacks up. The main statistics we care about here are the model's true positive rate and false positive rate. The true positive rate is the probability that we correctly identify a piece of AI writing, and the false positive rate is the probability that we incorrectly identify a piece of human writing. A perfect classifier will have a true positive rate of 100% and a false positive rate of 0%. Unfortunately, these two things are at odds with each other. A model that randomly guesses will always have the FPR and TPR equal to each other. But for a trained model, we can tune its sensitivity to get closer to this perfect model. This gives us the receiving operator characteristic, or ROC curve. A good model like GPT-0 is able to get a true positive rate of 98% with a false positive rate of 5%. And they're able to do this across all 8 genres of text and generations from 11 different models. However, our model was only trained on Wikipedia data and generations from GPT-5 Nano, so I don't have a lot of hope that it will perform that well. I was expecting to see decent performance on wiki-style text and generations from the GPT model family, but what I found was actually quite surprising. Here I have the ROC curve for our model, broken up by genre of text. And interestingly, our model is really good at identifying AI-generated movie reviews, and it's okay for Wikipedia and similar genres of text, and really bad at things like poetry and abstracts. This is pretty cool because even though it was only trained on wiki-style text, it's clearly able to generalize to other domains, and some domains seem to be easier than others. We can also plot just the TPR at FPR for 1% and 5%, and you can see that for reviews we're getting true positive rates of around 90%, which would land us in the top 10 on the leaderboard for that domain. For all the other domains it's a little more bleak, but still quite impressive given our limited training data. So, why does our model perform more poorly on the RAID dataset than our training set? My suspicion is that it's because the training data was split cleanly by paragraphs, where RAID doesn't really do that. This could explain why the performance on movie reviews was so good. These tend to be one nice paragraph of text. The other domains tend to be broken up into different paragraphs and sometimes truncated. We can also break performance up by model family. Despite being trained on generations from GPT-5 Nano, our model seems to work best on generations from Llama, which are Facebook's models. This could suggest that Llama's models are the most sloppy, but I'll let you speculate about that in the comments. As always, the code I use to generate my datasets and train and evaluate the model is available on GitHub. It's around 1,400 lines of Python. I also publish the model and the datasets on HuggingFace if you want to check them out there. This makes it super easy if you want to use the model for inference or for further fine-tuning. You can also use the dataset to train your own classifier from scratch. If you enjoy this kind of deep dive into different projects, you may also be interested in my last video where I managed to skirt around Apple's hardware lock on their Apple Foundation models. And if you want to see more videos from me in the future, feel free to subscribe. Thanks for watching.